Hello and welcome to a Minitab Express video on how to do stuff for Chapter 6. So as I've stated before, Chapter 6 is all focused on doing probability using distributions. So we're going to be looking at the binomial and the geometric probability distributions here. These are not the only ones that exist in the world. I think I've said this before, but at the same time, we only do the ones that we're going to be using to build normal distributions. So if you're wondering, why on earth are we only doing two if there's many out there? Well, the only ones we're going to need for what we do in Stats 1 and Stats 2, if you take it, are these two. So it's kind of trimmed down. So if you use the textbook at all, you'll notice that there are some other distributions in there, or if you read it, there are some other ones in there, but we don't actually do them in this class because we just don't, and I don't make that decision. So I'm not really sure why. Yay, being told what to do. Anyway, so as you see here, I have the exact same notes open as for the Minitab 18 video on doing this. The Chapter 6 notes, please note that these are notes, not an assignment. You're just supposed to use this to be able to follow along. It's a lesson. It is not something you turn in. So these first two questions have nothing to do with using Minitab Express or Minitab at all. It's just making sure you understand the difference between the two distributions. I do this in the other video, the one that appears above it, and it takes about 8 minutes to go through. I'm going to skip that for this video because I'm running low on space in your class. So if you want to see these first two questions, you will have to watch the first 8 minutes of the other video. Sorry. Let's get to doing some calculations. So the first one we're going to look at is a geometric. So we're looking at there are 20 marbles and 10 of the marbles are blue and, 20 red marbles, 10 blue marbles, and then 5 white marbles in a jar. We're going to select one at random, note the color, and then replace it back in the jar. So this is what we call sampling with replacement. And we're interested in the number of marbles you have to draw before you get a red one. So this looks like a geometric because the geometric is the stubborn guy. It's repeat until you succeed. Here our success is going to be having a red marble. So I'm going to mark some of this down. So just to keep in mind, our x is our random variable. And in this case, it's going to be the trial, or draw if you want, on which we get our first red marble. So you can think about getting red as a success. So that means our p, little p, notice there's a big difference between little p's and big p's. Little p is a proportion or a count out of a total, and it's not necessarily a probability. In this case, it happens to be. We usually use big P only for probability. So in this case, little p, since our success is getting a red marble, will be, this is going to be getting a red marble. A red marble, which in this case happens to be, how many red are there? 20 out, I'm having a hard time typing today. 20 out of 35. Let's make that a different color so it's a little more noticeable, which at this point you should pull up a calculator and ask yourself what that is, because Minitab does not take fractions. I'm hoping this is a pretty fraction. It's not, because I've already done this problem once before. So we're going to have to round this a little bit, and keep that in mind, because when you round these values, you are saying, oh, I'm only going to take this out so far, and therefore this will introduce some rounding error as we use that value. So I'm going to take it out more decimal places than I think I'm going to need, just to make it a little bit more accurate. This is just a good move for you. Okay, moving on to our first actual problem. Find the probability that it's a red marble on the first try. Well, that would be, how many tries did it take me? It took me on the first try, because x is the number of tries. Number of tries is 1 on which I get a red. So I'm thinking the probability that that happens. Yay! Well, how do you get a red marble on the first try? Well, that's the same as what little p is. So it's 20 out of 35, which we've already rounded and decided is 0.57143. So that's how it is. Good times. I don't need Minitab for this. There are several problems in here that you can totally get away with not using Minitab to do. But I'm going to try to do them using Minitab simply to show you how they are done on Minitab, because that's the purpose of these videos. Cool. So now I'm going to do this on Minitab. So I'm going to do some setup changes here just to make this fit on my screen a little bit better. So I've got the navigator window open, and I want that to be open simply because I want to be able to go back and look at some of my images and things I've done. There's actually no data in this, so I actually don't need the data window, so I'm going to change this to output only. So now I'm only seeing these two. So I'll get my navigation and I'll get the output I get from doing my tests and other calculations. So I'm going to go over to statistics. And mainly we're going to be using these two, the distribution plot and the PDF CDF. So CDF stands for cumulative distribution function. PDF stands for probability distribution function. So probability is just a single value, just one, which is all right. So since I'm interested in a single probability, I want to use PDF, just one probability. So I need probability density function, just one, not a continuous range. So it's going to ask you some stuff. The first thing it asks you is, do you have a single value that you're inputting, or is it many? So if you're doing multiple probabilities, like part A had like 4 or 5 of them you needed to do, you would maybe use a column. We're going to do just one. You more often than not will use just one. You'll probably never use the other one at all, ever, actually. Then it asks you what type of distribution are you doing. We're doing a geometric, so we need to put that in, and it is alphabetical, so thankfully geometric is right there. Sorry for coughing a little into the camera there. I'd ask you for your event probability. So remember, this is a probability of your success, also known as little p, and our success is getting a red marble, so that's that 0.57143. Ooh, I did not hit 0 there. Sorry about that. That would have definitely given us a little red flag there. I always put the 0 in because it makes it easier for you guys to see where the decimal is, so you don't actually need the 0. All right. The model we're doing is, yes, the total number of trials, and then it's going to ask you this following of how do you want it outputted? How do you want Minitab to report your answer? I'm going to choose display a table of probability density values because I turned off the data. You can ask it to display it in the column, and then it displays it in that data window that we earlier decided we just want to look at output. So now I'm going to hit OK. And it's going to produce it for me. So this is a little weird because you kind of got to read it vertically. It says, oh, here's your event probability. I'm counting the total number of trials. And so you kind of read it vertically. Little x is 1. And then when I look at the probability that big X, the thing I'm counting, is what little x is, which we already said is 1, then I get 0.57143, which matches me doing it without using Minitab. So there you go. There's how to use a PDF. So just to review, we hit the statistics tab, we go to CDF PDF, and we go to probability density function. And this is only going to work if you have an equal to. So if you have anything else going on, you're not going to want to use this guy. And I actually don't like this one as much because it doesn't produce a picture, and I'm more of a visual person. Just to give you my honest opinion about this. All right. So now we're going to go to, hey, find the probability that's actually selected on the 5th try. So I want the probability that the success, the red one, happens on trial number 5, not 1, 2, 3, 4, or above that. All right, so notice this looks very similar to A, so I'm going to show you a little trick here. On Minitab, if you're going to do something that's exactly the same as the one previous to it and just change 1 or 2 settings, you can use this button called Make Similar. Yay! And it brings up the last thing I did, or the last menu you closed. This won't always be useful if you have to use multiple menus to get something, so just keep that in mind. So the last thing we did was we did a geometric with it equal to 1. Now I want to do it equal to 5, or happening on the 5th trial, so just got to change this 1 to a 5. And then we hit OK. And there we go. And remember, we read this vertically. On trial number 5, okay, the probability that my success happens on trial number 5. And that's fairly small, which isn't too surprising when you think about it. 0, 19277. I'm sorry, I can't type and talk at the same time. It's not a skill I have. So looking at this, like, the probability of getting on the first try is like is bigger than 50%. So when you look at how likely you are to get little p, it's like, well, it should happen in the first 2 tries then if it's almost half. So, you know, if you want to guarantee it's going to happen, usually it's going to happen in the first 2. So how it happening on the 5th is actually pretty rare. So that means you had to have failed what should happen on average several times first. All right, let's move on to something different. So here's where things get a little bit more interesting. We're going to find the probability that it actually happened on the 5th try or something less. So 5th try or less. So I'm going to show you actually 2 ways of doing this one, but first I'm going to write my probability statement so I know what this looks like. So what am I counting? I want to be less than or equal to 5. And this is where I get mad at Word because I got to find the symbol for less than or equal to. 5th try or less. Symbol, there she blows. 5. Bing! All right, I'm going to make this look nice because that's who I am today. All right, so I'm going to show you 2 ways to do this one. The first one is just using the CDF because cumulative distribution function means I'm going to accumulate or add. So if you think about this, one way you could approach it if you wanted to do it by hand is to say, okay, I want 5 or less, which means I want 5, 4, 3, 2, and 1, and then add them all together. So you could go through and do these guys 5 times and then add them, but you already have 2 of them. So that's, it's not unreasonable as a way to approach this. It totally does work. But Minitab will do it all in one step because all it really takes is for you to calculate those and then add them. So I'm going to show you how to do this using the menu we just used, and then I'm going to show you the visual one, which might help you picture what's going on here a little bit better. Okay, so we're going to go back to CDF PDF. We're going to choose cumulative distribution function, as we're going to accumulate here. We are doing a single value, so notice this menu comes up with the default again, which is different from what we've had before because we're using the cumulative one, not the PDF, so not the probability one. So we're using CDF in this case. We're accumulating. So I want to do 5 or less, and it's going to know it's or less because I'm accumulating here. We always give it the last one on here, and it always goes to the left, so don't forget that. So if you have to do anything with a greater than, you're going to have to turn things around. But you know how to do that from Chapter 5. It's just 1 minus it. So we're going to go and do geometric. Got to put in my little p. 0.57143. Okay, and then number of trials, display in a table. We're good to go. This is going to look a little different from the previous ones. Okay, so one of these things is not like the other. We're annoyed with my singing probably already. Okay, week 3. Gonna be annoying. So x is 5, but oh, I want the values or the counts that are less than or equal to 5. So notice this matches what we stated with our probability statement. And it is different. It's much larger because it's looking at things that, happen on trial 1, trial 2, trial 3, trial 4, and trial 5, and adding them all together because they are all possibilities for when this success happens. So this is much larger than what you might think. Bing! All right. So there's how you would do it using the CDF PDF. I actually don't like using the CDF PDF menu, just so you know. It's a personal preference of mine. Not that that matters. I like using the distribution plot, the thing sitting just to the left of it, a little bit better. I don't know. I like the graphs because it helps me visualize what is happening here. So I'm going to hit distribution plot. We always use display probabilities. You'll never actually use any of these other 3 menus, even if you take stats too. Yep. And so now I'm going to change this to being a geometric to match this problem. It's going to ask you for your event probability because it always needs to know this. So you're like, if I'm not putting in little p, something going wrong. Well, that sounds inappropriate for a teacher to say. If I'm not putting in little p, something is going incorrect in my setup. There. Formal. Totally not my style. Total number of trials. Don't worry about changing the model. It's always this. We don't do any of the other types of models, just so you know. And then it's going to ask you this question. This is the one that stumps students a little bit. The area corresponds to a specified probability. So what this means is if you know what the probability is, it will find the x value or the value you're interested in, which is not what's going on. We know I want it to happen on 5 or less. Not a probability. So I want to specify an x value. I know a value, I want to find a probability. So this is the idea of garbage in, garbage out. Like when you input garbage into a computer, you can't expect it to produce something that makes sense. You know what I mean? So you can only tell the Minitab what you know and ask it to produce for you something that you don't know. So since I know 5 or less, that's what I want to tell it. Now let's do that. So I want 5 or less. So I know my x value is 5. That's my value of interest. And I want everything less than 5, or stuff on the number line that lies to the left of 5. So this is going to be a left tail. You almost never will use the equal tails. I'm going to show you how to do middle in a little bit, and I'm going to do one with the right. This one doesn't come up that often. You'll see it next chapter. I'll actually use it for something. It's a little weird, just so you know. But here we go. This is what it looks like. Let's go ahead and hit OK. I'm going to make this just a little bit bigger so you can see the whole graph. Aha! So I like this because it produces an image for you that shows you what the distribution actually looks like. So as you look at these bars, these are the probabilities for each value of x. 1, 2, 3, 4, 5, 6, 7. And on Minitab, you can float over them just like in Chapter 3, and it'll give you values. So notice this tells you, hey, yeah, if it happens on trial number 1, the probability of that happening is 0.5714, just like we told it. But what about happening on the second trial? Oh, it's a little bit smaller, 0.2448. 9, 8. And then there's 3, and here's 4. It's getting smaller. It's 5, 6, and 7. Notice it doesn't go above 7. It's probably so small you can't see it. Anyway, and then the other thing to notice about this is notice that it shades in red the area of interest. So I did less than or equal to 5 because I did cumulative. And the last thing to notice is it marks the well, not last thing, sorry, the value that you were interested in on here, not just any random value. Sometimes it'll give you some smaller one twos. It is kind of random. And then last but not leastly, your probability always appears above the value, so above the area of interest. So here's my probability, here's my value. Values along the x-axis, makes sense. Probabilities are associated with area, so they lie above. And notice it's the same as what we outputted using the CDF PDF menu. So these do the same thing. It's just a matter of, is the picture what you were thinking? So me personally, I like this because I can look at this and say, okay, the red stuff, what is it? 5, and the stuff smaller than 5. Yes, that matches what I was saying with 5 or less. And that makes more sense to me as a visual learner than as somebody who needs to have like calculations and stuff. So it's a way for you to sort of check yourself to make sure, does what my picture produce from this match what I was thinking, rather than relying on the fact that when I was doing calculations and just outputting a table, I think this is what I meant. You know what I mean? That's everything with the geometric. Let's get into doing the binomial. Woohoo! So the binomial question I totally made up based on a friend of mine who I was in a chemistry class where we had multiple choice quizzes every single week, and she hated that class, which was funny because she was pre-med, and that made me scared. This is not Professor Simmons, in case I haven't made that clear. So suppose Erin is going to guess on each of her multiple choice 10 question quiz. If she chooses a question that has if each question has 4 different choices, find the probability that exactly one of the 10 questions she gets exactly 1 correct on the 10 question quiz. Wow, reading is not a skill I have today. So I'm going to make some notes about this before we get started, just like I did with the other one. And this is just a good practice to ask yourself to confirm, is this a binomial or not? So you ask yourself as you look at what she's doing, what she's trying to count here is, oh, I want to get exactly 1 correct, I get none correct, I get at most 4, I get at least 4. Okay, I'm counting the number of correct questions she gets. So my x is going to be number of correct questions I was going to say number of questions she gets correct out of 10, but I'm going to abbreviate that evidently. Out of 10. And that out of 10 is very important because that's really hinting to you at, oh yes, this is out of something. I have a group of people, which tells me this is binomial. And that's always the next thing I look for. Or, yeah. I'm like, oh, how many times am I trying this? What's my n? Remember, binomial is the one where you can find n. N is always your sample size or the number of trials you're going to do. How many times is she going to try answering a question and getting it correct? She's going to try it 10 times. So, yeah. If you can't find that, you do not have a binomial. You cannot use this. All right, now what's our probability of success? So each question has 4 choices. And we're going to assume this isn't like my biology teacher. Yeah, this was my chemistry teacher, not my biology teacher. My biology teacher would do like options where 2 or 3 of them could be correct, and if you didn't get the 2 or 3, you got the whole thing wrong. Like if you got 2 out of the 3, it was wrong. That was kind of annoying. Anyway, so with us, it's just 1 out of 4 because there's 4 options. This is one of the ones that has like, like the whole like E, none of the above, and F, all of the above. Those are horrible. So her probability of success is just going to be 25% on 1 question. But remember, we're doing groups of 10 here and asking what's happening. All right, so now I'm going to write a probability statement for his first question. So we want to figure out the probability that she gets exactly 1 correct. So equal to 1. She wants to get 1 right, just 1. Q. So find the probability that Erin gets 1 of the questions right out of 10. So keep in mind with the binomial, it's not just she fails the first one. It could be the second question, could be the, not fails the first one. It's not she gets the first one correct. It's she gets 1 of them out of 10. And all the questions are different. So it could be the 4th one she gets right, could be the 5th one, could be the 6th one, could be the 7th one. And I'm hoping you realize here there are multiple ways that this could happen. And that's why we like the binomial for this, because it's complicated. I want to use technology to help myself with this. So since this is an equal to, it's a single probability, not multiple of them. So I want to use PDF, not CDF. probability density function. So I got to change this up a little bit. So yes, I do want single value, and I do want 1. And I'm going to change this from normal to a binomial. Now notice this asks you for more options. It wants the number of trials and the event probability. So it needs that n, yo. Notice binomial has an n in it also, and geometric does not. It's kind of a sneaky way, or not a sneaky way, a tip on how to actually keep these apart. Woohoo! And we're still doing table for this because it's the probability density. And I will show you how to do this on the distribution plot, but it's a little weird, just so you're prepared. Let's go ahead and hit OK. Ta-da! Okay, so the probability it happens on one of her questions correct out of 10 is 18%. So if you're her friend, you should be like, no, girl, you really shouldn't do this. It seems like a bad plan. I don't think you're going to make it. Maybe she's got other things in mind. I don't know. Depends on who she is. Yeah, I think I'm going to show you how to do this on the distribution plot now, and you might hate it. It's sneaky. Yeah. So kind of like as you look at these, they each have their own weaknesses and strengths. I think for this CDF, PDF, it's really great for singles, like just doing equal tos. But when it comes to doing less than or equal tos, I like the graph better. So when it comes to being an equal to, I actually hate doing the distribution plot for this. Do I want to do this yet? Nah, I think I'll do it later. Okay, so let's suppose instead Erin's like, no. You haven't convinced me with your just 1. I'm probably going to get more than 1. I think you're wrong. Because that's who she is. You didn't know her. It's fine. It's whatever. So you tell her, okay, I'll show you the probability that you're actually going to get none of these right. Which should scare her, right? Scared straight and all that jazz. So notice this is the exact same setup as A, except for the number of trials she gets correct or has the success happen is only none. So if you're thinking, oh yeah, I know how to do this, she gets them all wrong. So that's just 0.75 to the 10th power. Yeah, that's exactly how you do this by hand. Or we can hit make similar, since this is the same as A, on Minitabs. Pull this up and throw 0 in there. And then hit OK. That was a little fast. Ooh, that's really small. So this may not convince her. She'll be like, oh, that's not going to happen. Look how unlikely that is. And you should look at this and be like, teacher, lady, why is 0 smaller than 1? Think about it this way, if you're a little confused as to what's happening here. If I tell you you're going to take a 10-question quiz, and it's going to be super hard, and you just decide, I'm going to Christmas tree it, or make a pattern, or maybe I'm going to spell out my name in the dots and not care. You're randomly guessing, right? And you have a 0.25% chance of being correct. You're going to try 10 times. You're going to be right about a fourth of the time. So you do a fourth of 10, and that'll tell you exactly how many you should get correct. So what's a quarter of 10? It's 2.5. So that means, on average, you should get between 2 and 3 correct, or 2.5 correct. So 1 is actually closer to the mean, so yes, it's more likely, than 0. So that's why this is happening. It seems more reasonable that you get 2 or 3 correct, which is closer to 1, rather than none, by just guessing. In case that was unclear for you, hey, let's do some at mosts and at leasts. I always want to make these bigger so you can see them a little bit better. And then sometimes it fights me. So let's find the probability that Erin gets at most 4 questions correct. So think about it, at most. What does that mean? She can have smaller than that, but not bigger than that. So is 4 included? Yes, at most 4. The biggest it possibly is 4. So this is going to be less than or equal to 4. Insert symbol, no, 4. I forget, you always have to click back in here. So at most 4. I am going to use the graph for this. And then I'm going to show you some sneaky ways to get these two off that graph. So I'm going to go to distribution plot. I could have done CDF for this, I'm just choosing not to. Distribution plot, display probability. My big argument when they redid Minitab was that this should go first because it's the one students use the most. They didn't listen clearly. We're going to change this to nope, we're doing a binomial. Good job, teacher lady. Cool. Notice it has that number of trials thing happening again. Gotta know my n. Can't do anything if you don't know n. 0.25. It's hard to see. 0.25. Okay, once again, I know an x. I don't know a p. So I don't want the p's, which is what's labeled on here. I want the x's. Cool. So then I need less than or equal to. I want the stuff to the left of 4 or smaller than 4. That's going to be a left tail. Let's throw 4 in there and then hit OK. What do you think of them apples? Notice the binomial looks different from the geometric by like a lot. This is very typical. So as you look at this, there's 4. Notice the red is the shaded area of interest. So it turns out the probability she's going to get less than 4 correct is 92%. This is where she could be convinced that, you know what you're talking about. She don't know what she's talking about, and she's not going to pass this quiz. So there's that. So the sneaky way you can kind of get A and B off of this is if you click on the plot. Remember that trick of like hovering over? So I need 0, which is right here, and there is the value for 0. And you need 1, which is, right here, and there's the value for 1. So you can just leave your mouse hovered over the bricks to get it as well. So it's just a tricky way to do it. What else do I want to say about this? And notice, like, there is a bar for 0. That was one thing that was different about the binomial from the geometric. Since you're counting it out of a group, you could have that none of them have your characteristic. But back with the binomial, starts at 1. There is no 0 bar, because if you're trying to figure out on which try you get your first success, well, you have to have a first success, so you can't have no successes, which doesn't appear in this distribution. So that's how those two are different. All right. Let's do Erin gets at least 5 questions correct on her quiz. So, I'm going to be a little sneaky and just steal part of this. Or not, because it's fun. Teacher fail. I really am having a hard time getting this format to work for some reason. I apologize. It's bold now. That's fun. Leave it. All right, so I want the probability that she gets at least 5 questions correct. So if you have a hard time with at least, think about it in terms of carnival rides. You must be at least 5 feet tall to get on this ride. So if you're 4'9", it ain't happening. But if you're 6 feet tall, it's okay. So when you think about it as compared to 5 feet, it's the things that are bigger than 5 feet that are okay. At least 5. So the smallest you can be is 5 feet tall to get on the ride. This is going to be a greater than or equal to. All right, so I need greater than or equal to 5. You need stuff bigger than 5. Okay. So I'm going to show you several ways to do this. Here's the first one. So I want a greater than. This is our first time doing a greater than. So if you're thinking back to our cumulative distribution function with the CDF in this menu, this guy, it only does lefts, just as a reminder. So if you want to use this one, it's a problem, but you can get around it. Hope you're ready. So the way you can get around it is, okay, if I want the stuff bigger than 5, you can also do this as a not. So remember from chapter 5, to do a not, you do the stuff that's 1 minus the stuff that's not in there. So I want the stuff that's not greater than or equal to 5. And another way you can think about that is okay, well, I want 1 minus, well, what's not bigger than 5? Well, 4, 3, 2, 1, 0, and that's as small as it gets. So this is actually the probability that you're less than or equal to 4, which we just did. Sneaky, sneaky, sneaky. Haha. Okay, so notice no Minitab involved yet. If you think about this the right way, you can just do 1 minus the 0.92187.3. Why am I including all the decimal places? Maybe it's for fun, or maybe it's because I just didn't think ahead to give you a value to stop at for this one. Because, yeah, good times. So that's going to be 0.078127. If you're wondering how I did that, I just pulled out a calculator. So you can also use your Windows calculator or your calculator that you personally use. Now, if you hated that and thought, oh damn, what if I don't have the less than or equal to 1 already in a previous question, then this is more work. Why bother? You're right. Instead, let's let Minitab do the walk-in for us. So I'm clicking back to distribution, and I'm going to hit make similar because this is the same situation as we've had previously. And here's what I'm going to do. We want greater than 5, so stuff bigger than 5. On the number line, if you think about where 5 is at and the stuff bigger than it, like where is 6, it's the stuff to the right of 5. So I actually want a right tail with, 5 in there. So as you look at this, I'm like, what did I change? I changed from a left tail to a right tail because I'm doing stuff greater than, going the opposite direction of left, which is right. And my value of interest is 5. I want it to be 5 or greater. And then I'm going to hit OK. Oh my gosh, it comes out the same, but with more detail because there's more decimal places. It's just multiple ways to do this. So you could say like, oh, greater than. Wow, I can't type today. And yet I'm trying to make videos. Good times. I need to have some more coffee. It's not just greater than, it's or equal to. I wanted to show you this also because you don't actually have to use the symbols if you hate them. I kind of hate them sometimes because they annoy me. 0. I'm writing the same numbers twice. Why am I doing this? I don't know. It's my life. Anyway. Cool. So that's that. I have one less thing to show you, but for some reason that question is not appearing. Let's do one more. Do, 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 do. So we're going to make up our own D. So let's suppose this is who Erin is. She's decided she's going to get above a 50% and it's just not going to happen. So you're like, lady, let's see if she gets between. Let's say she wants to pass, but she knows she's not going to be all that successful. So let's say she gets between 6 and 8 questions correct on the 10-question quiz, including 6 and 8. Bravo, Erin. You got this, girl. Cool. So what would that look like probability-wise? Well, she wants to get between 8 and 6, including them. So, I'm going to steal this guy, because I don't want to go through symbol again. Live with it. Or don't. Judge me, because some of you don't talk to me at all, so that's fun. So between 6 and 8 is the smallest it could be is 6. The biggest it could be would be 8. This is what I'm looking at. Ha! I want in between these two, including them. And the reason I know it's including them is because it said so, and because there's an equal sign down here. Good times. So how do I do an in between? I would never do an in between using the CDF PDF menu because as you've already seen, it only goes to the left, which makes this incredibly complicated to do. So instead I would use the distribution plot because it does in betweens fantastically. So display probability. Oh, yeah, it defaulted back because I didn't use make similar. Oops, my mistake. All right, let's binomial this. Where's my binomial? Oh, it's at the top because it's in alphabetical order. There's 10 questions. She has a 0.25% chance of being correct, or 0.25. Remember, decimal only, not percentage. Whew, I have x values that I know, not probabilities. Cool. So as you look at these pictures, you're like, right tail, left tail, equal tails? I have 2 of them! This is the one I want! Yay! Middle! Alright, one thing to notice about middle and what makes this slightly complicated is notice the x1 lies to the left of x2, so that means it is smaller than x2, which means you always have to put the smaller one in for x1. So that one's always got to be the smaller of the two. La da da da. We are ready and set to go. So notice it matches kind of like what you might be picturing in your head for what the picture of this would look like. Let's hit OK so we can prove Erin wrong. Oh, that's tiny. I know I love this question and my making this up because I'm just like, let's be conservative. We're going to assume she doesn't get above an 80. But even then, it's still bad. 19, 6, 9, 8, 1. So as you look at this, if you were her, you should be like, girl, it's a less than 2% chance that you're going to get like between a D and a B. It's not going to happen. Please don't. Please don't do it. I believe in you as a person, but maybe study. Yeah, it's a fun time. Okay, so that's all I have for you today. So just a quick little reminder, we're using the distribution plot menu and the CDF PDF menu. As you've seen, CDF PDF seems to be the one that shines when it comes to doing equal tos, but doesn't produce any pictures, and it does lefts only, no rights. When it comes to distribution plot, it does all of them, but it does left, right, and middles much better, or in-betweens much better than it does anything else. And just to jazz you up a little bit, I'm going to go back to, where is it? Where's an equal to? I'm going to go back to A and do this using the distribution plot menu. Because I warned you the distribution plot was kind of terrible for this, but I'm going to do it anyway. So, oh, I can just hit make similar, that works. So as you look at this, you're like, okay, there's to the left, to the right, and between, we didn't use that one, and between two values, but there's nothing that's an equal to, because that's just one bar, not multiple bars. So how do you get around this? And there's a little faux trick you can do. So this is going to be the same as, and again, if you hate this, just don't ever use it, and then you don't have to worry about it. This is the same as saying, okay, I wanted something that's the same as being equal to 1, but is either a left or a right. So the trick that you can use to do this is say, okay, well, I'm going to do it in between and just be like, I want 1 only. So to have this make sense, I'm going to read it from left to right. I want all the numbers that are greater than or equal to 1. And I want all the numbers that are less than or equal to 1. Well, there's only one number that does that. That's x equals 1. So the only thing that's bigger than or equal to 1 and smaller than or equal to 1 is 1. So this is the same as looking at 1. So what I do is I do this as a middle and just put in 2 1s. I know this seems crazy. Just wait till you see the picture though. If you're already mad at me for doing this, don't even do it. It's fine. You don't have to do it this way. You saw other ways to do this. Ta-da! So notice it only lights up 1 bar. Good times. I feel like maybe you're watching this video and being like, why would I bother? Exactly. I do it because I like the pictures. Feel free to judge me. All right, now I'm done.